Hello, welcome. So today we're talking about dividing polynomials by what we call synthetic division. This is a different process than dividing by long division. In fact, this is a much simpler process to work through. And generally this works much better when we're dividing our polynomial functions by a binomial expression. No quadratics or anything like that. So in the Algebra 2 2018 edition for Glencoe, we're in section 4.3 on page 242. So like I was saying, synthetic division is a much simpler process to divide a polynomial by a binomial. We're using the coefficients of the polynomial and the solution of the binomial itself. If the binomial must have a coefficient of 1 in its variable and has to just be an x or a y or a b or whatever, it can't be an x squared or anything like that. There are ways to use synthetic division when the binomial does not have a coefficient of 1, but it starts getting, at that point, not as easy as it would be for just doing actual long division, so for problems like that, you're probably better off sticking with the long division method. So here's how it works. So we have x cubed minus 4x squared plus 6x minus 4 dividing by x minus 2. What we're going to do is, we're going to set up a little like L bracket, where we're putting the coefficients of this term right here, the x cubed, negative 4x squared, positive 6x minus 4. So it'll be 1, negative 4, 6, negative 4. Make sure they're separated out far enough so you don't possibly confuse them as like a negative 46 or 1 minus 4, stuff like that. We don't want to actually do that. On the outside of the L bracket, we're going to use the solution of the x minus 2 binomial, which is a positive 2. By solution, I mean if we were to set it equal to 0, what do we get for x? So the opposite sign. And from here, all the processes, and it's incredibly straightforward. We drop the 1 down. We always drop the first term down. And then whatever's on the bottom multiplies with what's on the outside. So 2 times 1 is 2. And then for our column, when we have two numbers here, we add them together. Negative 4 plus 2 is negative 2. Again, whatever's on the bottom multiplies with the outside. So 2 times negative 2 is negative 4. We again add. 6 plus negative 4 is a positive 2. We then multiply. 2 times 2 is 4. We then add. Negative 4 plus 4 is 0. Now, all we have is a bunch of numbers. What the heck does this mean? Well, if we work from right to left, the last number is the remainder. This is the constant term. This is our variable. And this is our variable squared. If there's another number, then be variable cubed, variable to the fourth, and so on down the list. So that means this answer, if we were to divide this by x minus 2, we're going to get x squared minus 2x plus 2 with no remainder. If you wish to confirm this using long division, feel free. But again, whenever we're dividing by a binomial expression with the 1 as the leading coefficient, so it's just x or just y or whatever, synthetic division, as you can see, is incredibly easier. All we're doing is working the coefficients, carrying down the first term, multiplying outside to the bottom, adding the column, and then multiplying outside to the bottom, adding column, multiplying, adding, until we get to the done, until we're done. Okay, so let's see another one. So we have 2y cubed minus 4y squared plus 6 divided by y plus 2. So when we set up our L bracket, hold on. There we go. Set up our L bracket. We now fill in the coefficients from the first expression. So we have a 2 for y cubed, a negative 4. We're missing the y expression, so it's essential to again put a 0 placeholder like we do with long division. And then a 6 at the end. And then it's always the opposite sign, so we'll have negative 2 on the outside. Like last time, we carry down the first term, and then we just start multiplying. Negative 2 times 2 is negative 4. We add them to get 0. Oh, sorry, negative 8. My bad. Negative 2 times negative 8 is going to be a positive 16. Add them to get 16. Multiply them to get negative 32, and add them to get negative 26. We're again working right to left. This is the remainder, the constant, the variable, and then the variable squared. So our answer should be 2y squared minus 8y plus 16, and then minus 26 over y plus 2. That's, again, all we have to worry about. Kinetic division, much, much easier. Definitely more preferable than long division if we can use it. All right, let's just work out one last one. So when we set up our L brackets, we're going to have an 8, a 0 for the missing b cubed, a negative 4, a 1, and a 4. Let me put the negative 3 on the outside. So we'll carry down the first term. We multiply again negative 24, which adds to be negative 24, which multiplies to be a positive 72, adds to be a positive 68, and then we're multiplying negative 3 and the 68, which is going to be a negative 204. We add that to get a negative 203. So you can see what the numbers are getting rather large now at this point. So then 203 times our 3, since both negatives will be a positive now, 609, which means when we add we get a 613. So, yay. This means we have a remainder, constant, variable, squared, and then variable cubed. So the final answer would be 8b cubed minus 24b squared plus 68b minus 203 plus 613 over b plus 3. I would recommend, the purpose behind this particular problem right here, even though you pretty much have figured out how kinetic division works at this point, and you're starting to get some rather crazy numbers here, is to start recognizing when the things are going to start increasing without bounds, either positively or negatively. Once you start having those big numbers start showing up, and you don't have bigger numbers, other similar double-digit numbers, or even possibly triple-digit numbers, as your coefficients in the problem, they're never going to cancel out. And they're going to keep on getting bigger and bigger and bigger. Because they're going to add, and while they might get a little bit smaller, then multiply with the negative 3 again, and they get even bigger. So, important to remember when we talk about ideas like the rational zero theorem, which will be in a couple videos from now, but just keep that in mind. Watch out for when it starts increasing without bounds. Alright, so that's it for kinetic division. So I will see you next time. Thank you for watching.